Now let's interpret our results for regression. This is the data from our 20 yarn stores example that we've been working on. And I have mapped out A to F, the different parts of this. So let's label this first line that says intercept as A. Looking at intercept, this line gives us the intercept for the sample data. So you've seen this before, 65.71. And then it tests whether the intercept is likely to be different from 0 in the population. So here's a reminder of our hypotheses test. And here's that t value that I talked about in the previous video. And then here's the p-value for that. With a p-value of 0.01133, that's less than 0.05, we will reject the null hypothesis for this test. Alpha is not equal to 0. Line B would be the part that gives us a slope for the sample data. So in this case, that was advertising. Let's see if I can line this up better. A, B. This line gives us a slope for the sample data. So you've seen this before also, 0.35. And then here's the t value for that. And here's the p value. And our hypothesis tests, the null hypothesis is that beta equals 0. And then the alternative is that it's not. Well, because the p value is 0.00769, which is lower than 0.05, we will also reject this one. Beta is not equal to 0. So together, the estimates on lines A and B give us the prediction model. And you've seen this before. That's where those numbers come from. The first two lines will give us what we need for the prediction model. Now looking at C, well, for this part, it's just giving us codes, which, I mean, really, we can ignore that because we just have to look at p-values here. So we don't really care, is what I'm trying to say. And then for D, we can ignore that line also. The residual standard error. Now, E, the multiple R squared, we'll talk about that more in a minute or two. Whoops. First, let's jump down to the F statistic, line F. So for this one, or wait, let me go back to D. I feel like I told you to ignore that, but didn't really tell you why. It's more of an advanced statistical topic, and so we're not going to get into that in this class. All right, going back to F statistic. Well, for this one, we can ignore this one because it's more something we look at when we, and when I say we, I mean statisticians, when analysts look at multiple regression. And right now we're dealing with simple regression, so there's no need to look at line F. So that brings us back to our prediction model and a look at our scatter plot that you saw earlier. So you've seen all this information before. Amount of traffic if store did no advertising, there's the y-intercept, and then for each dollar increase in advertising, that's associated with 0.3534 additional persons in the store. That's our slope coefficient. So in the population, based on our hypothesis tests and estimates, we cannot conclude that the intercept is in the population, that it is 65.7125. All we could say is that the intercept is not 0. And then we cannot conclude that the slope in the population equals 0.3534, only that it's not equal to 0. Now we can do a confidence interval for the slope, beta, which will tell us the largest and smallest possible slopes in the population, as confidence intervals do. The next thing to look at would be model fit and effect size. So this is when we go back to line E in our output, the multiple r squared, and then adjusted r squared. So we got two different values there. R squared is the coefficient of determination for a regression. So that's a capital R versus lowercase r squared, which is the coefficient of determination for correlation analysis. It's really similar. Now this R squared is an indication of how well the statistical model fits the data. The closer R squared is to 1, the better the fit. And the better the fit means that as it gets closer to 1, that means that these dots would be closer to the line. So that's great. However, R squared is always biased. It's overestimated. And smaller n and larger number of independent variables produce more bias. So what we really want to look at is the adjusted R squared, which controls for this bias. So we will use the adjusted R squared as a measure of model fit and effect size. Adjusted R squared indicates percentage of variance in the dependent variable explained by the independent variable. So in this case, it was 0.2963. So we could say that 29.63% of the variation in store traffic on Saturday is explained by advertising on Friday. So that leaves us with about 70% variation that's explained by other factors. And we talked about this in the previous video, right? It could be other factors like weather, local store characteristics, local competition, and such. So that would be the epsilon part in our model. All right, in the next video, let's talk about understanding prediction.